are still looking at circle theorems, and the level where we are now is we want to show that opposite angles of a cyclic quadrilateral are supplementary. The opposite angles of a cyclic quadrilaterals are supplementary. Now we want to use this a diagram to bring that into illustration. So if you look at this diagram, there are some informations that can help us here. We can say that okay, to show this now, we say required to show that x plus y. Let me not use x. Let me use because it's still the same thing. Required to show that A, B, C, this angle is equal plus, rather, because we are trying to show that they are supplementary. Okay, ABC plus ADC is equals to 180 degrees. This is what we want to show. Okay, how do we go about this? We will say construction, that is, if you join A to the center O, and C to the center O, you will realize that we are going to have AO being equals to CO, and both is radii. They are radii. Okay, this is a radius, both of them makes a radii because two of them are equal. They connect the center and the circumference. And if that is what exactly it is, it then means that hence we can now come from this understanding that AOC, this angle AOC, okay, is equals to 2 times ABC, okay, and we can back it up by saying angle at the center twice angle at the circumference. Okay, in the few classes behind, we have been able to do that proof clearly. So if you check out on those classes, you'll be able to follow what we did over there. Okay, so we have been able to show that this is this. It then means that AOC is equals to 2x. Okay, it's equals to 2x. Do we get that? I can call this star 1. Now, we also look at, this angle is AO, but the one on top is reflex. Ref AOC. The same label, but you attach ref to it, meaning that it is the that is greater than 180 degrees. Please know the difference between both of them. They are not the same. So I will also say now that having defined this, I will also say that also the reflex angle AOC is equals to 2 times ADC. The same theorem is what you are going to bring down here. Okay, the same theorem. It then means that this AOC is equals to 2y. I can call this star 2. I can call that star 2. Okay, now if you see what is comparing star 1 and star 2, comparing star 1 and star 2, you realize that 2x plus 2y is equals to 360 degrees. Why? This and this. Why? Angle at a point. The angle at a point is 360 degrees. So if you see this, you realize that you can factor out 2 and have x plus y equals to 360. So x plus y is equals to 360 over 2. X plus y is equals to 180. And what is x? 180 degrees. What is x? So we will now know that x is angle A, B, C from that diagram. And what is y? Y is ADC plus ADC, that it is equals to 180 degrees. Hence, the case is proved. So we have been in this discussion on this class been able to show that the opposite angles of a cyclic quadrilateral, they are supplementary. They are supplementary. So I believe that this diagram, the way I went into the explanation, my descriptions and all that was able to help us to understand how one can be able to show this proof. All right, there may be other ways to also show this proof. Please remember that our target is, when we are done with these proofs, we'll be able to use them, apply them in solving practical problems. So I adjourn you to be there so that you know when we start doing that. Of course,